Yeah, so we will start with some quick review of the concepts of week 6, and then I have some questions of solve with the speed. We will try to solve those questions as well, and we will see basically how to set the limits of in case of when you have two random variables, right? X and Y. Okay, so we say don't worry, we have enough questions. You'll get some idea. Okay, so which one was okay to all of you? Okay, okay. I can see a few thumbs up. Okay, like whether this sessions, revision sessions, and all were helpful for you guys, or assignments and all. Okay.
It was helpful, sir.
Okay, okay, great. So the one thing I can say, again, I will say, so you can see the level of quiz one, and similarly, you can expect the level of quiz two. So I will say again, don't please do not rely only on PYQ things, right? If you think you will solve the PYQ and you are going to score good or pass the course, then it will don't. So you have to do proper practice and you have to solve enough GA, PA questions and all of it. So do not rely on PYQ only. So it's not like
Yeah.
you get the same questions as PYQ. But there will be different questions. So you have seen the level of vision. Similarly, be prepared for your quiz two also.
Sir, for quiz 2, what would be the syllabus, sir? Is it from
Syllabus
6?
is week 1 to week 8.
Oh,
So
week 1 to
yes, major portion will be from week 5 to week 8.
week 5. Oh, okay, okay. Sure, sure. Thank you, sir.
Sir, but
So you can
week five
prepare
was already
according.
included.
Sorry.
Week five was already included in quiz one. So
Yeah. So there will be less weightage from week 5. Okay. But
okay,
week 5 will be in the syllabus. So as you can see, right, there was only one question from week 5, right, in quiz 1. Similarly, there will be less weightage from week 5 in quiz 2 also. But week 1 to week 8 is the syllabus. So again, I would say do not. So, okay, so one more thing, we saw few people are copying the G. Okay, so I would suggest try to solve the GA questions on your own so that you will get some sort of idea how to solve more number of questions based on different concepts and all that. So you can see there are lots of varieties in practice assignments, tutorials, graded assignments. Okay. So we have seen already few people are simply copying the G and they are submitting just to get 100, but that is not going to work in your quizzes, right? If you are simply copying the assignments and solving the PYQ and you are thinking you sit for the quizzes and you will score good. So that won't work. So something you have to put from your end. Okay? Some efforts you have to keep put from your efforts. So I hope this is clear to all, right? So be ready with the question. Be ready with questions. Do not rely on PYQ. You can solve PYQ because you will get some idea. Okay, okay, this is the concept, and suppose there is one concept. For example, let's say central limit theorem. So you'll get idea. Okay, so central limit. There are these are varieties. In that way, questions based on CLT can be asked, or questions based on, let's say, joint PDF can be asked or has been asked already. Okay, is this all right to all of you?
Yes, sir.
Sounds
Can
good.
you repeat quiz 2 syllabus again?
It's 1 to 8.
Okay, sir.
So 1 to 8 major portion will be from week 5 to week 8. Okay.
Okay, sir.
Okay. All right. Great. Then should we start week 6? How many of you covered some lectures of week 6?
Sir, I have covered today only the whole of it, but could not understand how to approach the questions.
Okay. What about others?
Sir, not similar scenarios.
Okay, anyway, so let me. I have solved this PDF. Okay, so we'll quickly go through the some concepts and then we'll try to solve the questions from solving this question. Okay.
Yeah, thank you, sir.
Okay. Is there any session from 8 p.m.?
Yes, maths session is there.
Maths session.
Yes, sir.
We will try to cover before that. Okay. No session we can extend. But anyway, let's see. We will try. Okay, so very first thing, so you have seen already, right? Till week 5, in week 4 itself, we started about continuous random variable, right? And you have seen the things for a joint PMF of two discrete random variable in week 1 itself, correct? So in week 6, what are the concepts basically? So see, the same concept, similar concepts, similar properties will be we have to use here. In case of discrete, we are using double summation. In case of continuous, we will use the double integration. Let me tell you what are the things. So firstly, we will see what is the jointly continuous random variable. Okay, and then second thing is we will start from here, and then we will see what is joint density. So in case of discrete, we have seen joint PMF, right? Can you recall?
Yes.
And here we will start what is the 2D uniform distribution as well. And then we will move on the, basically then we will see how to find, if someone asked, I forgot the name, how to find the limits for the double integration problem. Limits in case of double integration problem. Okay, this will be our next task. Then we will move on. We will see what is marginal density.
Sir, one
Okay.
more question, sir. How to solve the double integration also? That is also a question.
That will be covered. That's inherent in that. Don't worry. Then we will see independence. And then we will see finally conditional density. So these are things we will try to cover, and we have some questions also. We will try to solve those questions. Okay, let me quickly go through. So suppose you have seen in week 4, if x is a continuous random variable, what is the due date for week 6?
18th.
17th.
18th.
Okay. So please try to solve the GA on here. So what is the property? How will you check this is the valid PDF or not? There are some properties, right?
They have to be greater than 1 between a range, greater than 0 and 1, and the sum has to be 1.
See, this is the density. Density can exceed 1, okay? And I'm talking about continuous random variable. So you can't say this is some integration area under the curve should be
Equal to 1.
Equal to 1. And third one is f of x should be the piecewise continuous, right? This is something we have seen already in week 4.
Yeah.
Sir, would you please again teach us the piecewise continuous? What does that actually mean?
Have you attended the week 4 session?
Yes, but I was a bit...
I would suggest just go to rewatch.
Okay, sorry.
Okay. So see, piecewise just nothing but okay. Let me. So piecewise, suppose I'm saying f of x is defined something like this, some function of x here, and let's say for the range a to b. Okay. Then something here x cube plus 2, and from c to d. So this should be continuous here. This should be continuous here. All piecewise. So you can explore on. So this was the property for being a valid PDF in case of single random variable. Now we will see the joint density in 2 dimensions. Okay, so we will see what is the joint density in 2 dimensions. Okay, so as I see, till week 4 you've seen just 1D. Now it's a 2D, right? 2 dimensions. Now the first thing, what is, I will write the technical definition. So a function, okay, a function f x comma y. So this will denote the joint density, right? is said to be a joint density function. Okay, when your f of x is a valid PDF in case of single random variable. Yeah, tell me.
The area under the curve is 1.
Area under the curve is, that's all. That is the one property, or there are, I just discussed few seconds ago.
For all the
f of
values,
x should be
x should
greater
be
than
greater
equal
than
to 0.
Should be greater than equal to
And
0.
should be piecewise continuous.
Piecewise continuous, right? So it's a joint density function, correct? So first thing, if this f of x comma y, this joint, this would be greater or equal to 0, and then area under the curve is which you will integrate throughout the support of x. Okay, so this is first integration. Let's say I'm talking about x, and then y. This whole thing should be equal to 1, and the third one is this fx comma y. This should be piecewise continuous. Okay. So this will be piecewise continuous in each variable also, because we are talking about in 2 variables. So you can explore more on it, this piecewise continuous and all. So let me quickly go through the content. Okay. So how to proceed in this case? So in case of single random variable, suppose I am interested to calculate probability x less than 1. How will you start? We started from, let's say, lower limit is minus infinity, then it will be minus infinity to 1 f of x dx, right? This is something we have seen.
Yes.
Correct? Now, in case of 2D, how to start? So you have to see whatever the things you have defined, including x, y. So x comma y, let's say this, there is something defined with a, right? In a. So what you have to do? You have to do the double integration for this part, and what you have to integrate, this joint density you have to integrate. Okay, you will see some questions related to this. Before that, there is something. What is the support of x comma y?
It is the value where both xy densities are non-zero or
Non-zero, right?
greater than 0.
Yeah, correct. This is something we have seen in case of. Okay, let me start with the example. Maybe that will give you the more clear idea. So very first example is, suppose I'm saying let x and y have joint density function. Okay. So I will take very simple example. So let's say I'm saying x have joint density f of x comma s. This is 1, and support of x is 0 to 1, and support of y is 0 to 1, and it will take value 0 otherwise. Okay. So far so good. Now, so very first question is, my first question, what is the probability that x will be between 0 and 0.1, and y will be between 0 and 0.1. Okay. So to solve this question, okay, there are 2 ways. Okay. So what are those 2 ways? First, let me start. So what you have to do, whenever you have been given this kind of question, okay, try to draw the graph. Okay. So what will be the, so suppose this is x, this is y. Okay. So then support of x is 0 to 1, right? And support of y is 0 to 1. This is whole things, right? Correct? Yes or no? Are you getting my point? And this is 0. So our interest of area, so suppose this is 0.1 and this is 0.1. So we have to calculate this part. I'm interested in this part, right? This shaded region. Are you getting my point? So what is the, this is one of the square, right? You can see. What is the area of a square?
Sir, 1 by 100.
Sorry?
0.01.
0.1 into 0.1 area
correct.
square.
So basically you will get 0.01. 0.01, right? This is the one way.
Yes.
Another way, you can start with this our usual 2D part. So let's see how to integrate. So how will you solve this part? First of all, so let's say I'm writing what is the fx comma y, fxy So I'm writing dx first. So what is the limit of x? 0 to 0.1. Then dy, what is the limit of y? 0 to 0.1, correct? So now you will do 0 to 0.1 and 0 to 0.1. And what is this fxy? It is given as 1 only, correct? Now, so what you will do, first you have to integrate with respect to x, and then whatever the things you will get inside this curly bracket, and then you have to integrate this part with respect to y. You can do vice versa also. You can write here dy and then dx, not a problem.
dx को आगे पीछे भी कर सकते हैं.
Sorry?
Sir, dy dx को आगे पीछे भी कर सकते हैं.
Yes, you can. So doesn't matter. Answer you will get same. Okay.
Yeah, because at the end we put the value.
At the end you will put the value. Correct. So if you will integrate this one, what are the things you will get? You will get x, right? And then you have to put the limit 0 and 0.1 and dy, right? Then this will be 0 to 0.1, and if you substitute upper limit minus lower limit dy, and then this will be 0 to 0.1 and 0.1 dy. Now since 0.1 is the constant, I can take outside, and if you will integrate 0 to 0.1 again dy, what else you will get? 0.1 y 0 to 0.1. So it will be 0.1 and 0.1 minus 0, and at the end you will get 0.1 into 0.1, which is same as 0.01. Is this clear?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, let me take another example. Suppose I'm interested to calculate what is the probability that x will lie between 0.5 to 0.6 and y will be between 0 to 0.1. Okay, suppose this is my question, and if you see
Answer will be the same.
okay, so answer is same, that's okay, but let's try to solve this. So what I'm trying to give you idea how to solve this 2D. Okay, so this is first of all my total support of x and support of y. Now I'm interested, x is 0.5 to 0.6. Suppose 0.5 is somewhat here and 0.6 is somewhat here, and y is 0 to 0.1, right? So suppose this is 0.1. So my area of this is the area in which we are interested.
Yes, sir.
Yes or no? Now what is the area if you calculate? 0.1 into 0.1 again 0.01. Yes or no? Correct. Now
Yes.
that's the from the graph only. If you solve this, let's try to solve this. Okay, tell me how should I proceed? So first of all, I can write, and I will write fxy x comma y. Let's say I'm writing dx first and dy second. You can do it. So what is the limit of x? First I have to substitute 0.5 to 0.6. What is the limit of y? 0 to 0.1. Right? So this will be 0 to 0.1, and here it will be 0.5 to 0.6. It's a 1 dx, right? Yes or no?
Yeah.
Now if you will solve this, you will get 0 to 0.1, and here it will be x, and 0.5 to 0.6 dy, and it will be 0 to 0.1, and again 0.6 minus 0.5 dy, you will get 0 to 0.1 dy. Again you will solve this, you will get 0.1 into 0.1, which is same as 0.01. Yes or no?
Yeah.
Okay.
Yes,
So understood, right? You are getting how to write this part in terms of integration. Yes or no? Is this rough idea so far clear to all of you?
Yes, sir.
Yes.
Yes, sir. But the activity questions are tougher. Those questions.
One second, let me teach in general. Okay, so first of all, everyone should get idea. Okay, I will come to that point. I will first go slowly. Okay.
Yes, sir. सही है.
So see, the thing, we have to give you idea, right? So others is your job. Just try to solve. If you are not getting, we are here. Okay. So I will come to a bit tricky part. Don't worry. Okay. Now the third question. Suppose as of now it was very simple. So now, okay, whatever the joint density we gave, let's rewrite again. So it was 1 for the support, 0 to 1, and y is also 0 to 1 and 0 otherwise. All right. Now my question is, so as of now we discussed very simple things. So my question is, what is the probability that x greater than y? Okay. So whenever you will see this kind of question, So what will be your very first approach?
Draw the line y is equal to x. Then you take the upper half of it.
So the very first step, whenever you have been asked this inequality, correct? So what should be your first step? So step 1 should be, if there is some background noise, can you please? So whenever you be given this kind of greater than, less than, so draw line for equality. So draw x equal to y. Okay, this would be first thing. Okay, so and then you have to okay, let me draw first of all. Suppose this is x, this is y. So if you will draw a line and this is 1, correct? Y, what is the maximum support for y and x? Both are 1, right? So if you draw a line x equal to y, so this is the line of x equal to y. Would you agree with me?
Yes, sir.
Yes,
sir.
I'm interested in x greater than y. So which one is the greater, lower part or upper part? Just think a bit.
lower part, sir. Lower part.
Lower part.
Lower part, right? If I'm substituting any value here, let's see. So this value is x is something 0.5, but here y is less than, right? Yes or no? Are you getting?
Yes, sir.
Yes, sir.
So lower part is, so to get this idea, just take any value. So suppose I'm taking any value here, right? So this is x is greater, right? So x is around close to 1, but y is less than 0.5 only. Are you getting my point? So this is the area in which we are interested, right? So this is the area we have to calculate probability x is greater than y, correct? Now, so there is two approach. First of all, approach 1 is you can apply the concept. I mean, this is a triangle, right? Okay. So what is the area? I'm interested in this part, this dotted part. So what is the area of triangle?
Half.
Half.
Length into breadth.
Into height.
Area of triangle. So this is half. Base is 1. Height is 1. This is half only. Okay. Yeah, base is 1, right? This is 1 and this height is also 1.
Yes,
correct?
sir.
Now we will see the second approach, which is our usual approach. If you don't have any area formula and all, in that case, how will you proceed? So I told you, you have to draw a line. So first, your first step should be draw a line. This x equal to y, and then find this part. Whether you are interested to calculate this probability x greater than y or probability x less than y. Okay, and then after this, you have to find the limits of x and y. Now, how to proceed this part? Okay, so you can fix anything and you can proceed for another. Okay, suppose I am interested to calculate the limit of x. Okay, so give me a second. Hi. Okay, so what was the first is you have to find the limit of, okay, suppose I'm interested to calculate the limit of x. So there is one approach how to proceed. So whenever you can go in either way also. Suppose I'm interested to calculate the limit of x, then what I will do, I will have to draw a parallel strip or parallel line with respect to x. Okay, suppose I'm drawing a parallel line with respect to x, and then we have to identify the limit. Okay, so this line is x equal to y, correct? Yes or no? This line
Yes.
is, and what is this line?
Yes, sir.
This line is,
X into y. No, x.
this is 1 only, right?
X
what
equal
is
to 1.
Here, if you see x is going from y to
1.
See, if you see in any part, if you draw a line parallel to x axis, if you see from anywhere to anywhere, x is going from y to 1, yes or no?
Yes, sir.
Right? So this line is x equal to y line. So here what is the value of x? Y. What is the value of x here? 1. So what is the limit of x? Y to 1. Okay. Then how to proceed? So first of all, if I'm interested to calculate the probability x greater than y, so in that case, what will be the things? You have to integrate this joint PDF with respect to dx and dy. So what is the limit of x? It's a y to 1, and what this is limit of x. And in the second integration, what is limit of y? It's a 0 to 1, right? Because
Yes,
y
sir.
is moving from anywhere, right? I'm not a restriction. There is no restriction on y. I'm just keeping and just try to finding out the limit of x first. Okay.
Sir, would you please repeat the how did you find the limits? I found it
See,
confusing.
if you want to calculate the limit of x, okay, you can go in either way also, right? So you can find the limit of y also. I will come to that. So suppose I want to calculate the y of limit of x. Then what I will do? I will draw a parallel line or parallel strip with respect to x axis. Okay. Then if you draw the parallel line with respect to x, then see from where to where it is going. So if I have drawn this line, this is going from y to 1 in this area, right? Wherever we are interested, right? Yes or no?
Yes, sir.
If you draw any line, you can see it is going from this line. This line is y, and this line is 1. It's going from y to 1, right? What is the value of x here? Y. What is the value of x here? 1. Yes or no?
Absolutely.
Okay. So you can see, so in the 2D integration, what will be the limit of x? Limit of x will be y to 1 and dy 0 to 1, right? There is no restriction on y. Okay. So there is two ways I can solve this integration. And the second one is, this is one way. I can find the limit of y also, right? There is no restriction. You can start with limit of y. So what is the limit of y? If I want to find the limit of x, I will draw a parallel line with respect to x-axis. If you want to find the limit of y, I will draw a parallel line with respect to y-axis. Yes or no?
Yes.
If I will draw a parallel line with respect to y-axis, suppose I am drawing like this. What is the value of y here?
Y is 0 to 1.
0 to 1. Just think about
X,
it.
X.
Not the X.
It is going from here,
X to
x-axis
Sorry,
to
sorry.
here, right?
S.
And limit of y,
0 to x.
limit of y
0
on
to
x-axis
x.
is 0 to
Zero.
x, right? Are you getting my point? Now, what will be the case? So, this is 2D integration. So, fxy, x comma y. First, I will substitute the limit of y. And what is the limit of y here? 0 to x. And limit of x, I will take the whole limit of x. So, what you can do? You can take whole limit of one variable and you can keep restriction on the another variable. Okay. So, we'll see this integration and this integration, and we will see whether we are getting the same answer or not. Okay. Does this sound good?
Sir, can you explain again how did limit of y came?
So limit of y, I told you if you want to calculate the limit of x, so first I will draw a parallel line with respect to x. Okay. Then you can see the red line, right? So if you see the red line is going from where to where? What is the value of x in that situation?
Y to 1.
Y to 1, right? So I took a limit of x as a y to 1, and you can see when you are taking y to 1, in that case your random variable y is free, right? There is no restriction on y. So I will take limit of y is 0 to 1. Yes or no? Are you getting? I can draw anywhere this red line, correct? And y is 0 to 1 only. Now if I want to calculate limit of y, okay, then in that case I will draw a parallel line with respect to y axis. So this is the parallel black line, if you see. So black line is going from where to where?
0 to y.
0 to y.
X.
0 to x, right? This is x equal to y. So what is the value of y here? X, right? So this is 0 to x. So I can take value of limit of y 0 to x, and you can see in that case x is free. I can draw here, I can draw here, I can draw here, anywhere, right? X can take 0 to 1. Are you getting my point? So you can take you can proceed in either way. Okay, it's for your interest. Now let me solve this question. Okay, first of all, this limit is okay as of now. I will solve some more questions also. Don't worry, it will be more idea. Okay. So let me solve this question. Y to 1. What is the fxy? This is 1, right? And I will solve with respect to x first, and then this is dy. What is the limit of y? 0 to 1. Now 0 to 1. If you solve this, I will get x, and this is 1. This is y. Dy. Yes or no? 0 to 1. I will substitute the limit. I will get 1 minus y dy. Clear? Now, yes or no? Are you getting this integration basis?
Yes,
Yes, sir.
Yes,
sir. See, at least say yes. No, otherwise I won't get whether you are getting this part or not. So this is 0 to 1 y dy, correct? If I will solve this, I will get y and 0 to 1 minus
y square upon 2.
correct, 0 to 1. So if I will solve this, I will get here 1 minus 0 minus 1 by 2 minus 0. So basically I will get half. Yes or no? So you can see you got half, and while by the area of triangle again you got half, right? Answer is same. Now let's cross check whether I'm getting the same answer with this integration or not. Okay. So if you see that part, or else I can start with this part. So fxy is 1, and what is the limit of y? 0 to x. First I will solve with respect to y, and this final version I can keep the same limit 0 to 1. So 0 to 1, and it's a y, and 0 to x dx, and you solve 0 to 1. So if you substitute here, it will get x minus 0 dx, and basically you'll get 0 to 1 x square by 2 dx, and sorry. So this shouldn't be the case. This will be x square by 2, 0 to 1, and it will be 1 by 2 minus 0. So you can see we got the same answer. Yes or no?
Yes.
Okay.
Yes, sir.
So let me change again inequality a bit so that you will get some idea. Okay. And let's say D part. Suppose I'm saying I'm interested to calculate probability x greater than 2y. Okay. So according to this, what should be my first approach? This is
X is equal to
X is equal to 2y.
First, I have to draw. My first step should be I have to draw x equal to 2y, right? So x equal to 2y will be first of all, this is 1. This is 1. Okay, so x equal to 2y will be somewhat like this. It shouldn't be here x equal to y line, right? Are you getting?
Yes, sir.
So
Yes.
this is x equal to 2y. This is x equal to 2y. So which region you are interested in? Lower one or upper one?
lower.
Right? X is greater than 2y, right? Now, so suppose I'm interested to calculate. Let's do in reverse order. Reverse order means suppose suppose I'm interested to calculate the probability. Not probability. No. So first I will start. Let's say limit of y. So okay, if I want to calculate limit of y, what should be my first approach? Tell me. Parallel to y-axis, right? If I'm drawing a line parallel to y-axis, what is the limit of y here? It is going from 0 to
0 to x by 2.
0 to x by 2. Here you can
X
see
by 2.
x equal to 2y. So what is the value of y? X by 2. So limit of y will be 0 to x by 2. And x can take any value from 0 to 1, right? You can see I can draw a line here, I can draw a line here, I can draw a line here. X will take value 0 to 1. Yes or no? Are you getting?
Yes, sir.
So what I have to do?
Yes,
I will
sir.
integrate this joint PDF of xy with respect to dy. What is the limit of dy? 0 to x by 2, and then dx. And what is the limit of x? 0 to 1. So it's very simple. Again, you have to just solve this. 0 to 1, 0 to x by 2. This is 1 dy. First, I have to do this integration, and if I will solve this, I will get y and 0 x by 2 dx, and if I solve this, I will get x by 2. I have to integrate this x by 2 dx, and 1 by 2 outside, I will get x square by 2. Yes or no?
Yes.
Yes, sir.
Let me take one more step. So x dx 0 to 1. So half x square by 2, 0 to 1. So if I solve this, I will get 1 by 4, 1 minus 0. So 1 by 4 is the answer. Is this clear now?
Sir. Yes, sir.
Yes, sir.
Sir, for calculating y, we need to constant y value and vary x, right?
Here y is varying. I mean, yes. So basically, x can take any value, right? X is free. If I'm interested, suppose you are interested to calculate the limit of y, then x is free. If you are interested to calculate the limit of x, then y is free. Okay?
Sir, sir, some doubt. Sir, what is the use of restricting the limit in 2D densities, and why we are not restricting the densities in 1D density? Sir, what is the difference?
What is that? See, in 1D, in single rectangle, it's very simple. If I'm interested, if I will say you to calculate the probability, let's say x is lies between 0.5 to 0.6. Okay, for example. So you know what is the PDF of x. Suppose PDF of x something like this. You know, suppose this is 0.5 and 0.6, right? And you have to simply integrate this part, right? In case of 2D, you don't know, right? Then you have to this is the way you have to calculate the limit of x and limit of y. Okay, so because we are not talking about the whole area. Okay, so suppose here we are, if you see in this question, if see here limit of y, I'm interested at 0 to 0 0.1, 0 0.5 to 0 0.6, right? So it was clearly mentioned, right? Then in that case, I didn't keep any no restriction or something like that. Yes or no? I simply integrated. X is like from 0.5 to 0.6, y is from 0 to 0.1. I solve the integration, I got the answer. Similarly, I did here, right? What if there is any inequality? So if x is greater than y, you don't know what is the limit of right? So you see, if you take limit of y 0 to 1, x is 0 to 1, you will get 1, right? You will integrate because you are integrating the area under the curve. Okay.
Yes, sir.
So we have to to solve this inequality, we have to first, I will draw x equal to y line, and I will identify in which region this inequality is fulfilled, right? Satisfies this inequality. Then I will look up, okay, so if this is the area, then in this area, see, if you cannot integrate the whole things, right? Then I will see, okay, so there is one restriction. I'm interested in this below region only. Now, what will be the limit of y in this below region? If what is the limit of y is going from here to here, then x is free, right? X is free. X can take any value from 0 to 1. Or else I will see, okay, what is the limit of x? Then you can take that. Okay, so at the end you have to calculate some value. Okay, so we'll see something.
Sir, I have a doubt. In the question you have solved for y is equal to 2y, x is equal to 2y. Instead of taking limits on x, if I solve with limits of y, it is not coming for me. Would you please help me?
See, that's what I did. I solved for limit of y.
No, not for y, x.
So if you take limit of y, it will be 2y to 1, right?
So it will be from 2y to 1, right? Huh? Yeah. And the other will be 0 to 1, right?
0 to, okay, tell me what's it? 0 to 1, you should write.
Oh, no. It's not 0 to 1, it is something else. No, y, which one are x? No, this should be half, 0 to half.
Just think, yeah, so here in this case, if you draw a parallel line to x, y can take any value from 0 to 1, right? But
that should be 0 to 2, right?
That's what I'm saying. Just think a bit. What should be the limit? Okay, just substitute these values.
You just take the lower limits and upper limits and substitute in the x greater than 2y, then you will get the limits.
You'll get the limit. Okay. Just think a bit. If still you are not getting, we will solve this.
Sir, if x is less than 2y is asked, then how should we take the limit?
If x is less than 2y, you are in upper part, right?
Yes, sir.
Then you can draw a parallel line with respect to y or x. So if you draw a parallel line with respect to y, then y will be x by 2 to infinity, right? Sorry, x by 2 to 1. X by 2 to 1, correct?
Yes, sir.
And x is free. Then accordingly you can solve. Okay. So that's why I told x is greater than 2y or x is less than y. Okay. So
sir, for this question, can you help once again with the limit of x?
Which question?
The same question, the D part. X is greater than 2y.
Yeah, tell me, according to you, what should I write?
So I'm just
It's a
trying to
limit of x.
understand here. Yes. So y might vary from x by 2 to 1.
Okay, okay. I will do. Okay, so why I'm not telling you, just to keep you just think of it. Suppose I will do, I let me take something for probability x. Okay, in that case, in this case, if okay, what was the limit of x? I simply draw limit of I mean parallel line with respect to x, and I got 0. Sorry, y to 1, right? Because in that case, y can take any value from 0 to 1. So just observe this time. It is going from till 1, right?
Yeah.
Is that the case? Whether it is y is going from 1 or 0 to 1, or where is this half or something like this? Repeating
So
my point. What I'm trying to give you a hint.
So x will go from 0 to 2y and y will go from 0 to half here if you do the x dx dy, the limit of x.
Are you getting my hint? What I'm trying to say?
Yeah. Yeah. Yeah.
Okay.
So why you're saying y would go from 0 to half only, right?
So I'm not giving you a clear answer. I'm just saying, just think a bit. Just think a bit, right? I
Sure.
can give you just okay. So what I would suggest, just think a bit, solve this, and let me know whether you are getting 1/4 or not. Okay. If
Sure.
not, you are not
Sure.
getting. I will solve it. Okay. Does
Sure.
this sound good?
Yeah, yeah, thanks.
Okay. Yeah. You got the idea, right? What I'm trying to say. Initially, x equal to y line was this, right? And y can move from 0 to 1 if I'm drawing a parallel line with respect to axis. Now, this is not a case. Understood?
Yeah.
Okay.
Sir, in first y down part, sir, I didn't understood.
Why?
Sir, I got -1/4. That is the question. Why am I getting minus?
No, then it's calculation mistake. What was
No,
your values?
So the x values would go from 0 to 2y and y value would take from 0 to half. So then you would just get the half.
Access. Sorry. Can you come again? Yeah, can you come again, please?
Yeah, so x will go from 0 to 2y and y will go from 0 to half.
X goes
0
from
to
2y to
see.
1.
First of all, I will draw a parallel strip to one second. Someone is saying he got answer in negative, right?
Yes, sir.
So what are the limits you took?
2y to 1 and 0 to half.
Yes, sir. मेरा भी यही. 0 to x by 2, not half.
See, one way is I can calculate with area of integral, right? I mean area formula, right?
Yes, sir, but I want to know this.
So the area, so if you look into this, the limit of, when you're computing the limit of x, so it should go from 0 to 2y, right? So it can, the maximum that it would go is the 2y, that would be the domain, right? And
Okay.
for y, it should be the 0 to half, because 0 is the lowest limit that it could take, because 1 cannot be a possibility, right? Because that's what you do when you just given given a very generic function. That's what you would do if you are given, say you are not able to draw an x equal to y line here. What you would generally do is to just put the values and check what would be the minimum and upper bounds of the given function and then integrate over that.
One second. So see, I want to draw this part. No, why this page is not moving. Yeah, it's working. sorry. See, I want to draw this part. I want to limit x greater than 2y. So what I will do, first of all, if I want to draw a parallel strip with respect to x axis, so this is going from 2y to 1, right?
Yes, sir.
Yes or no? X is going from 2y to 1, right? And what is the limit of y? Y is going from where to where? See, in the previous question itself, I asked you, right? So, the previous, when it was x equal to y line, then y was moving from 0 to 1, right? But in that case, y is restricted only to this blue line, right? So, what will the limit of y? Half only, correct? Y cannot go till 1. Are you getting my point? Yes or no? See, in this case, x, okay, we draw both line. That's what I told you. Just think a bit, but anyway, you put some effort from your end. See, this is x, this is y, and this is 1, right? Y was taking maximum value 1, and y is x is x maximum value 1, and this was the line of x equal to y. Okay. And I told you if x is suppose I draw parallel line to with respect to x axis. So x is from y to 1, and y can take any value from 0 to 1, right? Yes or no? So y is, so this is 1 limit, right? This is 1, right? Are you getting my point? This is 1. This is 1. Are you getting? Y can take any value, right? From here to here, any value, right? It's free. Yes or no? So x is y to 1, and y is 0 to 1. Yes or no? Is this okay?
Yes, sir.
Yes, sir.
Now, while in the second graph, if you see, this is x, this is y, this is 1, this is 1. Okay, so this is my whole support of x and y, and now this is one part, right? Now this is not 1. I'm interested in till half only, right? I'm not interested till 1. So why is this? So this is x equal to 2y limit, right? 2y line. Yes or no? So if I will draw a parallel line to x with respect to x axis, so this is 2y to 1. Yes or no? And it can take any value 2y to 1. What is this line? This is going only 0.5 only. Yes or no?
Yes, sir.
Are you getting my point? So if simply just substitute. What is the upper limit of x? It's 1. Right? If upper limit of x is 1, and what will the value of y in that case? Half only. Are you getting? So limit of x will be 2y to 1, and limit of y will be 0 to 0.5. Yes or no? So are you getting my point? So for this line, so this black line where x equal to 2y, in that case y can take any value from 0 to till 0.5 only, right? I'm not interested here, right? Line is not till here, so that y can take value 1. Y can take value from 0 to 0.5. Is this clear? Here you can see this,
Yes,
this line is x equal to y, and this is, if simply if x is 1, y is 1. Here if x is 1, y is half. That's all. Is this clear now? So those who had doubt in this part, is this clear? Yes, no?
Yes, sir. Yeah.
Right? Clear to all, right?
Sir, can you go back to the screen? The screen is
yes, please. Yeah.
So the question is why x goes from 2y to 1. Can you explain that? That is confusing actually. Why you are saying 2y to 1?
No, this line is what? This line is x equal to 2y line, right?
Yes.
So what is the value of y x here? 2y.
2y. Okay.
So just see, this line is going from here to here, right? If you see, okay, what is the limit of x here? Y is to 1. Y to 1, because this line is x equal to y.
Correct.
Value of x is y. This line is x equal to 2y. So what is the limit of?
Okay. So 2y to 1. Okay.
Right. And here y can take any value from 0 to 1, right? It can take any value from 0 to 1. But here y cannot take any value here 1. This line is
that part is Correct. That part is clear. The limit of y is 0.5. It is
0.5.
limited to 0.5.
So
Yes.
if you will integrate this part, if you do just solve this, who did so it's a 1, and what is the limit of dx? It's a 2y to 1, and limit of y is 0 to 0.5. So just solve this and let me know whether you are getting 1/4 or not. Okay. Okay. Should I move ahead to the next concept? It's already 7. Yes, no? All right.
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Sir, in first question, in x greater than y, why we take the down part, sir? I didn't understand that.
See, just take any value. Suppose you are taking any value here. Okay. What is the value of x here? Suppose this is somewhat close to 0.5. Okay. What is the value of y here? This is something less than 0.5 only, right? So which one is greater? X is greater, right? Just take any value and just see whether x comma y and which one is greater.
Okay, so x value anywhere, sir.
Anywhere, yes. So
Okay,
in this whole region, you will find x is greater than y. Okay.
yes, understood, sir.
Okay, so the next concept is called something 2D uniform distribution. Maybe you will see something. Okay, as of now, the rough idea is clear regarding this double integration, find the limit of x and y. We have some questions. We will try to solve that. Is that okay?
Yes.
Okay, so let me quickly go to this part called the 2D uniform distribution. Okay, so what is this 2D uniform distribution? So what is the basic idea? So suppose I will fix some region D in R square, okay, in 2D basically I'm talking about, okay, with the total area. If you are not getting, don't worry, the definition will solve some question. What is the total area? So this is this mod of D basically. So we see, this denote the total area. So we will say that x comma y, this is in uniform D if they have the joint density so when what is the joint density? Fxy is nothing but 1 upon this is area of D. Okay, whenever this x comma y, this pair belongs to D, and it will take value 0 otherwise. So this is nothing but this is area of D. So you have to find the area of D and you have to do substitute the you have to basically do 1 upon. So what is the D usually we define? So let's say this is Cartesian product of A comma B and C comma D. So how to read this part actually? So this is nothing but this x comma y such that your x will be between A and B and y will be between C and D. Okay, so for any basically, okay, so you can see, so this will give you the support of x, this will give you the support of y. Okay, so for any sub-region A, okay, so in the given region of D, so any sub-region A of the D, so how I will calculate the probability x comma y, this is in A, this is nothing but area of A divided by area of D. So this is area of A divided by area of D. So basically, you know what is the, how will you calculate the probability? Probability is nothing but is what? Favorable case divided by total case, right? So this is something favorable case divided by total case. Okay. So I have some example. I will quickly go through that. Maybe that will give you the idea. Suppose my question is x comma y is from uniform. Okay, just be with me. It will be clear in a minute. So this is uniform. Let me write somewhere. What I'm saying, x comma y is uniform. Okay, and what is this? So suppose 0 comma 1 and 0 comma 1, and it's a union of, I'm talking about. If you are not getting, don't worry, it will be clear in a minute. how to proceed in this problem. And whenever you will watch lectures, so I would suggest do watch lectures. You will get more clear idea. Okay. So this is the union of this thing. So I told you, right? If you have A comma B product, this cross say C comma D, so this will give you the area support of X, and this will give you the support of Y, right? Now, so whatever the case, how will you proceed? So first of all, my question is, suppose I will say, draw the region, okay, and find fx comma y. Also, this is something my question is, find this. Also, find probability that x is greater than y. Okay. So first of all, I will draw this part. Okay. So let me draw.
Sir, what have you written? 0, 1 into 0,
1, 1, 0, 1. Okay. So now, so first of all, this is limit of x, limit of y. So this is 0, this is 1, suppose this is 2, and this is suppose 3. So you can see here in this part, in the what is the first part? X is 0 to 1 and y is 0 to 1, right? Okay. So x is 0 to 1 and y is 0 to 1. So I mean, this is the area. Yes or no? Yes or no?
Yes, sir.
Right?
Yes,
union
sir.
of, what is the union of 1? X is 1 to 2, y is 1 to 2. So x is 1 to 2. So x is 1 to 2 and y is 1 to 2. So this is the part. This is square thing.
Yes.
Right?
Yes.
Union of x is, x is 2 to 3, but y is 0 to 1 only. So I'm saying x is 2 to 3. Forgive for my bad drawing, and y is 0 to 1. Understood? Are you able to relate now?
Yes.
Yes, sir.
So let me, so as per the given graph, so what this is the part and this is the part we draw, and this is the part. Okay. So this is my D. So what is the area of D? How will you calculate? So this all are square. Okay. Just consider this a square actually. Because of my bad drawing, it doesn't seem so proper square. But anyway, so first of all, how will you find this is draw the region I drew. Now the thing is, I have to calculate joint PDF. So we saw the definition, joint PDF is nothing but 1 upon area of D, right? So what is the fxy? X comma y is nothing but 1 upon area of D. So area of D, first of all, what is the area of D? So area of D is nothing but, what is the area of first square?
1.
1 into 1, right? Plus area of this part?
1.
Again 1 into 1 plus area of the third square?
1.
3. So what will be the joint PDF here? It's
1 by 3.
1 by 3. Clear? And it will take value whenever this x comma y inside the D, and it will take value 0 otherwise. Now it's fine? Yes or no?
Yes, sir.
Yes.
Now the next is, I have to calculate probability x is greater than y. Okay. So there is 2 ways. I told you, right? So I'm interested in this sub region. So x is greater than 2y means what? First of all, I can draw x equal to y line. Just try to relate. Actually, I'm not able to draw properly. This is x equal to y line. Yes or no?
Yes, sir.
Yes, sir.
Okay. So if this is the x equal to y line, if you see, then I can find the area of D. So there is 2 ways, right? So I can, first of all, I can find the area of D. Area of A and divide by area of D. So what is the area of A? Basically, I'm interested here. X is greater than y. So what is the greater than y part? Below or lower?
Lower.
Lower part, right? Let me use some another color, blue color. Lower part, all this lower part, right? X is greater than y. Yes or no? So if you see here, what is the area of this? This is a triangle, right?
Yes,
I can find this area. I can find this area. Yes or no? What is the area of first blue triangle? So it's a half into base. What is the base? 1. Height is 1 plus. What is the area of this triangle? Half only. Now this is not a triangle, this is a square, right? Because below this line this is a square only, so area is 1 only, correct?
Yes, sir.
Yes, sir.
Are you able to relate what I'm doing here?
Yes, sir.
Yes, sir.
And divide by area of D is, what is the area of D? 3.
Yes.
Right? So if you see half plus 1, it's a 2 by 3. So answer is 2 by 3. Clear? See, you can do integration also. So if you will do integration, then what will be the limit of x here? It will be 0 to 1. What will be the limit of y? Or else you can go in reverse order also. But I think this area is simple things, right?
Yes, yes, sir.
Let me take another example. In that example, I will show you take the limits also. Okay, so let me take another example. So x comma y, let's say I'm saying this is from uniform D. Okay, and what is the D first of all? So let's say D is defined as, now let me change a bit. Suppose I'm saying 0 to half. 0 to half, and this is the, let's say, union of make it half to 1 and half to 1, just for. So what is the limit of x here? 0 to 1 by 2, 0 to 1 by 2, 0 to 1, half to 1 and half to 1, right? Now let's try to draw the graph. So suppose this is x, this is y. So x is 0 here, and suppose 1 by 2 here, and 1. So there is 0 to half and y 0 to half. So this is half, this is 1. So this is the first square, right? And 0 to half y. So this has been covered here, yes or no?
Yes, sir.
This is union of half to 1 and half to 1. So basically, I'm saying half to 1.
The upper square.
Upper square. Okay, so just please draw a proper square while you are trying to draw. Okay, understood?
Yes, sir.
Okay. So now, what is the area of D here? What is the area of D? If I were to calculate, so area of D will be
sum of both squares.
Yeah, that I'm asking to you. What's the area of D here?
1.
Half.
1 by 2.
Sir, 1 by 4 plus 1 by
Half
4.
into half, 1 by 4.
Yeah, it's a half into half, right? So
1 by 4.
Right? 1 by 4 for this plus 1 by 4.
1 by 4.
Right? So basically 1 by 2, this one, right? Yes or no?
Yes, sir.
And what is the joint density will be? It's the 1 upon area of D. So 1 upon area of D is the 2, right?
2. Yes, sir.
Correct? So now my question is again, what is the probability x greater than y? So suppose I want to calculate probability x greater than y. What I will do? I can draw a line x equal to y, right?
Yes, sir.
And greater than part is below 1. So you can apply the area formula also. So x again, what I can do? I can do the integration. What I will do? Let's say I'm saying this fxy, x comma y, and suppose I'm interested in dy. What is the limit of y here? I have to draw parallel line to y-axis, right? What is the limit of y here? 0 to x. This is x line, right?
Yeah.
Okay. And then what is the limit of x? It can take any value 0 to half. So this part has been covered. Plus, what about this part? If I were to draw a parallel strip to y-axis, what is the limit of y? Tell me.
Half to x.
Half to x. Very good. So this is half. Y is going from half to x. And what is the limit of x?
Half to 1.
Half to 1. Now you understood, right? How to find the limits? Okay. So if you solve this, you will get the same answer. I'm not solving because we have to cover another concepts also. Okay. Okay. So far it is good.
Yes, sir.
All right, great. Now this is something you have seen 2D uniform. What if you have 2D non-uniform? Means you have something else, some again inequality and all. Okay. So what is the 2D non-uniform? Let me. I will start with the example only. Okay, maybe that will give you the idea. 2D non-uniform distribution. Okay, so in case of uniform, what you did to calculate the joint density, you will say 1 upon area of D. But now what if you don't have 2D non-uniform? Okay, so let me take, I'm saying X comma Y have joint density, okay, such that suppose fxy is given to you as, let's say, x plus y. Okay, this is given to you, and limit of x and y. So x and y is 0 to 1. So what? How will you interpret this? This means x is also between 0 and 1, and y is also between 0 and 1. Okay, it will take value 0 otherwise. So question is, you have to find probability x is less than 1 by 2 and y is less than 1 by 2. And suppose I added twisted x plus y less than 1. How will you proceed? Okay. So first of all, what is the solution? How will you proceed first of all? So if you see, what is the support of whole x? X is going from 0 to 1. Y 0 to 1. This is my total area, right? Yes or no? Total support. So if you see, I'm interested in to calculate x is less than half and y is less than half. That means suppose half is here and half is here. I'm interested in this region only.
Yes, yes.
So I can do two things, right? Either I can simply calculate area of this. So probability x is less than half, y is less than half. I will solve this. I will get 1 by 2 into 1 by 2, which is
1 by 4.
Should I do 1 by 2 into 1 by 2?
1 by 4.
No, the x plus y is equal to 1 or something. What was the condition? Yes. So
okay, just
less than 1.
Less than 1, right? Should I do this 1 by 2 into 1 by 2 or something else?
1 by 2 into
No,
1 by
sir.
2 to 1 by 2. That is x plus y is equal to 1.
Yes, sir, of course.
Sorry? Yeah. Should I do 1 by 2 into 1 by 2 or not? Should I start with the integration part? Just think a bit.
Sir, we'll integrate.
We have to draw maybe the x plus y equals 1 line. So it's easier.
No, this is second question. Second question. I'm first calculating this part.
Sir, we can't multiply because they are not independent.
Okay. So see, this is, I'm talking about non-uniform. Okay. So it's better to start with the integration part. So how will you integrate? Let's see. So this is the area of x is going to 0 to 1 by 2, right? Because what is the lower limit of x? It's 0. See, this joint density is not 1. So initially, how did we compute it? Because joint density was 1, right? Area under the curve was 1 only, right? Are you getting my point?
Sir.
Here, x plus y, this joint density is x plus y. Understood?
Yes, sir.
Okay. So this will be 0 to half. And what is the limit of y? 0 to half only, right? Because I'm interested in this part. What is the fxy, x comma y? So dx, dy. Should I solve this or is this okay? I can skip. This is the basic. If you want, I can do. I don't have any problem. So this is x plus y dx. And first I will. So you got the idea why I didn't multiply? Yes or no? Because this is not, area under the curve is not one, right?
Not uniform.
Yeah. So now here it's a 0 to 1 by 2, and here I have to do with the integration with respect to x. So 0 to 1 by 2 x dx. And can I write y is a constant? I can take outside, yes or no?
Yes,
Y
sir.
constant because I'm integrating first with respect to x only, right?
Yes.
Then 0 to 1 by 2, it will be x square by 2, 0 to 1 by 2, and this will be y into x. This will be 0 to 1 by 2, and this part will be dy, and 0 to 1 by 2, this will be 1 by 8. 1 by 8,
Yes, sir.
right? Plus y by 2 dy. Yes or no?
Yes.
Okay. So can you solve this? I'm just skipping this fine. Just solve this, right? Just solve this. You will get the answer. Okay. So I'm just giving you idea because we have to solve the some more questions. That's why I'm skipping. Okay. So
Yes,
the
sir.
next part is probability x plus y less than 1. This is the question. Yes. So this is
Sir?
the probability x plus y less than 1. Yes.
I did not understand like why we don't multiply it.
This is non-uniform, right? It's not a uniform also. They are not about uniform. So another thing you can think like this here. Just think a bit more, right? You are not trying to think that's not. Yes. So here, what is the fxy? It's already 1, right? You know this area under the curve is 1. Okay. See, it's 1 only. It's just a constant. Here is the fxy is constant? No, right? It is x plus y. There is something, some another graph, right? It's not, you will get a square. Are you getting my point? X plus y, you have to draw for x plus y. Are you getting? Initially it was 1, just a constant. Okay. So, yes, no, anything? Yes.
Okay,
Okay.
sir.
So this is 1, right? Upper limit of y is 1, lower limit of, so this is, I told you what should be very first step? You have to draw x plus y equal to 1, right? So what is the x plus y equal to 1? This is the line x plus y equal to 1. Yes or no?
Yes.
Yes.
And this is the whole support. Now this is the line x equal to 1. What is x plus y less than 1? This left side or top or lower or bottom?
Bottom.
Bottom? Would you agree? Everyone would agree? Yes or no?
Yes.
So suppose I'm interested to calculate here limit of y. How will, so what should be my very first step? I have to draw a parallel line to y axis. Okay, if I am drawing a parallel line to y axis, what is the limit of y? It is going from
0 to 1 minus 6.
0 to 1 minus x. Very good. Because this line is x plus y equal to 1. So what will the value of y? Y equal to 1 minus x.
1 minus x.
Is it okay? So how will you proceed? So 0 to 1 minus x, you have to integrate the joint PDF, which is x plus y, and first this is dy, and then you can see dx. X can take any value, right? 0 to 1. Would you agree with me?
Yeah. Yes, yes.
All right. Any doubt?
All right, sir.
Okay. Now let me change again. Let me change a question. Now just please solve this. Right. This is something you have to do from your own, your end. So let me change. I'm just trying to give you some different kind of questions. Suppose this is have joint density. Okay. And what is the joint density? Suppose I'm saying this is 4xy. Okay, so those who are having doubt this multiplication and all, just think of it. Okay, initially it was just a constant I draw. Now it's there will be something different for 4xy, right? Suppose I am interested to calculate probability that x is less than 1 by 2 and y is less than 1 by 2. How will you proceed? I have to do integration 0 to 1 by 2 4xy, yes. Let's say dx. Okay, then you have to integrate with respect to y. So what is the limit of y? 0 to half. Because it's clearly mentioned, right? Yeah. Now, yes. Suppose in the same case, again I'm saying I will take some 2 to 3. Suppose I'm saying probability x plus y less than 1. Okay, so how will you proceed in this case? See here, y, this is x, upper limit is 1. Yeah. This is y. So this is x plus y equal to 1, right? I will draw first line x, right? So what is the, okay, suppose I want to do in reverse order. Initially I did for something y. So what is the limit of x? This is for quick revision. Tell me, what should I do? I will draw a parallel line with respect to x-axis. What is the limit of x here?
0 to 1 minus y.
0 to 1 minus?
1 minus y.
So what I will do? I will integrate 0 to 1 minus y, 4xy. First I will integrate with respect to x, and then y can take any value between 0 and 1. Does this sound good? What if I will ask probability x is greater than y? What you will do? The same graph, this is x, this is y. I will draw a parallel line with respect to x equal to y, right? Yes or no? Suppose this is 1. I'm just doing a quick revision. The same thing we did. So what is the limit of, tell me what is the limit of x here?
Y to 1.
Y to 1.
Y to 1. What is x greater than y first of all? Lower part or upper part?
Lower part.
So this is y to
1.
Y to 1. Correct? And what is the limit of y?
0 to 1.
0 to 1.
0 to 1. What if I will ask probability x less than y? What is the limit of x? First of all, x less than y means I'm talking about the upper part, right? So limit of x will be 0 to y. Yes or no?
Yes, sir.
Okay. And then what is the limit of y?
Sir, a small request. Someone is like using some wrong mic. The S represent 25F100. Could you just
okay, it's muted already. Okay, please, if you don't end out, please keep the music. So this is 0 to 1 right here. Is this okay to all of you now? Yes, no? Clear, right?
Yes, sir.
Sir. Yes, sir.
So this is the way you can proceed. So the next concept is, I will quickly go through this. It's called marginal density. Okay. So in case of discrete random variable, you have seen already. If you have okay, so in case of discrete, what you did? In case of discrete, if you want to calculate probability marginal PMF for x, what you did? You did the summation over the support of y, and what you sum is you sum the joint PMF, right? And if you want to calculate the marginal PMF of y, and you did the summation throughout the range of x, and then you added the joint PMF. Yes or no? This is the way you did. Can you recall?
Yes, sir.
Yes, sir.
Okay.
Yes,
So
sir.
in case of continuous, what we will do? We will just simply integrate, right? This integration will replace with the continue. So this summation will replace with the integration. Okay. So if you have joint density fxy x comma y, then first, if I will say x has the, it's called marginal density. How? So if it will be marginal density, I will represent as f of x. So what I have to do? I have to integrate the joint density with respect to y. Okay. So here you did summation for all the possible values of y, right? And then similarly, y will have the marginal density. Okay. How? So fy of y, how will you proceed? So you will integrate this joint PDF with respect to x. Would you agree with me? Yes, no?
Yes, sir.
Okay. So whenever you have been given the joint density, if you integrate with respect to x, you will get marginal of y, and if you are integrating with respect to y, you will get the marginal density of x. Is this clear?
Yeah. In the first equation, is it fx of x?
Yeah, this is fx of x. So basically, suppose that suppose I told you, right, this fx of y is given to as a 4xy, for example, okay, and this was the support, right? And my question is, it will take value 0 otherwise. Suppose I am asking you have to calculate the fx of x. How will you calculate? You will integrate the joint PDF with respect to y. So what is limit of y? 0 to 1. Whatever the value, you will get whatever the things, you will get marginal density of x. So this is something you have to integrate 0 to 1. 4xy you will integrate with respect to y. Now to get the marginal density of y, I will integrate 0 to 1 this 4xy with respect to dx. Understood?
Yes, sir.
Okay, so I'm not doing the integration. We will see
Sir.
some
Sir,
questions.
how did you get the limits as 0 to 1 means from
It's
normal?
given in the questions. Okay. So something, yes.
In lectures, sir has taught, he spoke about some slicing. Could you just, what
Yeah,
is
that's
that?
what. That is the same thing for this, right? If you want to if you want to find the margin and all, you have to keep that slicing part. Okay. So we'll see that one. Don't worry. Okay. First
Sir,
one.
I feel what you have written is easier. Like, just copying the limits given in the question. Like,
so actually, just try to rewatch. Actually, sir is trying to see. Here we saw this graph and all, right? How to find the limits and all. Sir is trying to give you the idea, give you the flavor about if you are doing the marginal. So marginal means you are not considering whole things. You are considering some part, right? Some slicing part, right? That's what sir is trying to give you some idea. Anyway, just try to rewatch. Still, you are getting any difficulty. We are here.
At the end, the limits will be, the same which you have written, where excluding.
Correct.
Okay.
So this is, see, whatever the things I discussed, this is just a trick. Okay. So, and sir is trying to give you the visualization also, right? So that you can get, okay, so there is nothing which is going something blindly or randomly, right? Everything is, you can visualize some. So that you can just try it out. What I would suggest, just try, saw the lectures once and try to draw that figure. Okay, so here see, I took only very few examples, few specific example, right? This x greater than y, x is less than y, x is greater than 2y. What I would suggest, just try something, try to take some difficult, x is greater than 3y or something, x plus y is lies between 1 and 2, something like that, right? So that you will get, and try to draw the graph, and if you are facing any difficulty, do let us know. We are here, or you can simply if you are trying any problem and you got stuck in between, take a screenshot and just send your picture or how did you approach. You can tag to us on this course. This is the question I tried like this, and this is the where I got stuck. So help us. We are there. Okay. Fine. All right.
Yes, sir.
Okay. So I will try to give you the idea about this independence part. So I will start with the events. Okay. So there is something called, you have seen, right? This is something we have discussed already. So suppose you have two events, events A and B. Okay. You have two events. So I will say when two events are independent. Anyone? When you will say two events are independent?
Probability of intersection B is probability of
Sir, when their joint probability is product of individual probability, marginal probability.
Okay.
What about when the events are disjoint?
See, disjoint and independent, both are not same. Both are totally different. Okay. So disjoint is a different thing. See, two events are independent means I will say if happening or non-happening of the second event doesn't affect the happening or non-happening of the first event. What I mean, probability that A given B, this is same as probability of A given B complement, whether B is happening or not happening, this is same as probability of A. Understood?
Yeah.
If I'm writing B given A or probability B given A complement doesn't affect the happening of B. Understood? This is the meaning of independence, right? There is no relation at all. What is the meaning of disjoint? So disjoint is A intersection B is, there is nothing common. Okay. So if you see this formula, actually, so there is conditional probability formula. Probability of A given B is nothing but probability A intersection B divided by probability of B. So from here, what else I can write? Probability of A intersection B is nothing but, can I write probability of A given B into probability of B? Yes or no?
Yes, sir.
So this probability of A given B by the independence definition, I can write probability of A. So this is the way to check the independence of two events, means intersection of those two events, probability of intersection of those two events is equal to product of their individual probabilities. Now if you take probability of here, this is probability of phi is what? 0, right? So this is disjoint event. So be clear with this disjoint and independent. Now, so this is in terms of events. So if I talk about in terms of random variables, so random variable x and y are independent. Okay, if this fxy, x comma y, first of all, I will say this joint PMF is equal to product of their marginal joint density is equal to product of their marginal density. Are you able to relate these two?
Yes, sir.
Or I can say the conditional density is equal to the margin. Okay. I think who is this? Please be mute if you don't have any doubt. So are you able to relate this? So probability of A given B, I will say, is equal to probability of A, this same thing. F of x given y at a particular value of y, x equal to f of m. Is this clear? The definition is okay?
Yes, sir.
So whenever you have to calculate this joint part, conditional part, you can start with this. Okay. So one more thing, actually, I will quickly go through that. So conditional density. So see, if I'm writing like this, so f of y given x equal to, let's say at a specific value of a y. So what will be the see, as per the definition, this intersection divided by marginal, right? So here it will be fxy, and what is the value of x? I'm taking a comma y, right? Are you getting my point? See, I'm
Yes,
just
sir.
okay. Let me write in general first of all. This, can I write fx of x?
Yes. Yeah.
Huh?
It's Bayes theorem, right, sir?
See, it's not a Bayes theorem, it's a conditional probability actually. Bayes theorem will, yeah, kind of Bayes theorem, yes, you can say. Bayes theorem is also one of the conditional probability. So if I will write f y given x equal to a at y, so can I write fxy a comma y divided by fx of a? I'm just calculating density at a particular value of x, right? Are you getting?
Yes,
If I
sir.
have to calculate fx given y equal to y, then what will the numerator part? Numerator part will be joint density divided by fy of y. Would you agree with me?
Yes, sir. Yes.
So is this clear? So whenever you have to calculate the conditional probability, you have been given the joint and you have to divide with the marginal. Okay. All right. So far so good.
Yes.
Okay, great. Then let's start with this peer deck slide. So please join it fast. We will try to solve some questions. Okay. So I see major concepts I have covered from week 6. We will try to solve some questions.
Sir, so you have covered all the topics in week 6, right?
Yes, yes, yes.
Okay, thank you, sir.
Quickly I have covered. So this is you know how to join this. Just just enter on your browser joinpd.com, and then you have to enter the code. So code is you can see this is AXOSAZ. Okay, so please join it fast so that we can start this session.
Sir, what is this? Just
So-
to solve the problems.
See, there's something I have some slides actually. So whatever the things I'm going to present on my screen, you will be able to see on your screen. The thing is, you will be able to give the input of the question. Okay, so you solve the question, you will give the input. I will be able to see what are the input has been given from your end. Okay, basically, and I will allot some time limits so that you will get some idea. Okay, so these kind of questions I'll be able to do in 2 minutes, or this kind of questions I'm able to solve in 3 minutes, or something like that. Basically, you will get some sort of idea. You'll gain some confidence. Okay, so just try to join it. So in your browser, either in your phone or desktop, whatever you have, just write down joinpd.com, and then after that it will ask to enter a code. So code is AXOSAZ. So whatever the concept we have quickly covered, we will try to solve those. So 16 of you have joined. I will wait for 1 more minute. Please join it first. If any one of you is facing any difficulty, please do let me know. joining this PDF.
Sir, is solve with a session graded?
Graded means you will find the questions similar to graded assignments. Okay, means you will get some idea how to solve the question. Okay, so this is the very first question. Okay, so you have to find the value of k. How will you find the value of k? You have to do the area integration. The area under the curve will be 1. Okay. So this you can recall from single random variable, yes or no?
Yeah, that we do from 0 to infinity for both the variables. That
Or
would be equal
both
to
the variable, yes, because lower limit is 0 and upper limit we don't know. So 0 to infinity. Okay, so just do the 2D integration from 0 to infinity, 0 to infinity, you will get, and equate it 1 and you will get the answer. So I have allotted 3 minutes. Try to solve and let me know whether you are getting or not.
Sir, what is the integration of e to the power minus x dx?
So it's e raised power, basically if you want to integrate, you'll do integration of e raised power ax dx. So this will be e raised power ax divided by a. Okay, now you have to decide what is the a and all.
Sir, is it k value 1?
Don't know, need to check. So do you want extra time? Anybody?
Yes, sir.
1 minute or 3? Okay, let me give you one.
Sir, is it e squared?
No, I don't know. I need to check. We will see the solution.
Sir,
Okay.
Sir, one thing. So e power minus
A
x
is equal to 1.
We'll see the source. Don't worry. Yeah. Let me
Sir,
see the
e power minus x plus y, we can split into e power minus x into e power minus y,
Yes,
and
yes, yes, yes.
apply integrals.
And you can do
individually.
Actually, value of k is 1. So you can see here what the solution is. So it's 0 to infinity, 0 to infinity, right? So it's you can see its x is greater or equal to 0. So lower limit is 0. It can take value till infinity, right? Then 0 to infinity, y is also 0 to infinity, dx dy. And if you solve this, so this e raised power minus x plus y, you can split, right, for your own convenience, right? Because you can split by the mathematics. So it will be, then you can integrate this respect to x and you solve this. At the end, you will get value of kh1. Okay. So there is one concept. So this is e raised power. If you want to integrate e raised power ax dx, this is same as e raised power ax divided by a. So if you have e raised power minus x dx, so instead of a, we have minus 1. So it will be e raised power minus x divided by minus 1, and just substitute whatever the limits of x and y is given. Okay.
Sir, sign is also will be taken from A.
Yeah, so a is what here? Just try to relate this part, right? So here I'm saying e raised power ax dx is e raised power ax divided by a. So what is the a? Instead of a, you have minus
A
1.
here is -1. A is -1.
Understood? So if you have e raised power ex dx, if you integrate, you will get e raised power x only. Okay. So the next question is the same question. I mean, the joint PDF is same. This probability has been changed. Just try to apply the limits and let me know whether you are getting the answer. Okay. I mean, is there any one of those? Understood? So what will the limit of y here, x here? From where to where you will integrate?
4 to infinity, and from y would be 0 to 4 only.
0 to 4, because lower limit of x is 4, but upper limit of y is 4. Okay. Okay. Anyone? Do you need extra time limit?
Like 1 more minute.
Yes, sir.
Okay. Okay. All right. Okay. Well, anyone? Do you need extra time level? Should we proceed? Yes. No.
Yes, sir. Actually, I could not write the answer.
Okay. So 30 second.
Yeah.
Okay. Oh yeah. All right. So let me see the responses. Oh wow. So lots of options are there. So majority is going with option. So majority is with option number A. Okay, with option number B also. Let's see which one is the correct. Okay, all right. So if you see the limits, so it's a x limit of x will be 4 to infinity, and the limit of y is 0 to 4. Okay, so if you solve this, I'm not going to do this integration part. Okay, so if you solve this all this integration things, so you'll get e raised to minus 4 into 1 minus e raised to minus 4. I think B option is correct, right?
Yes.
I think
yes, sir.
By mistake selected option here. Okay, anyway, so you got the idea, right? How to proceed with this kind of questions? Yes, no?
Sir,
Yes, sir.
sir, once please open the solution of the first question.
This one.
Yes.
Is there any doubt?
Sir, once we are able to select the correct limits, then all we have to do is integration.
Integration, yes, yes. So limits is the important part. Okay.
Yes.
So now, so this is the something you have to apply the conditional probability part here. Okay. So okay, so what you have to do here in this case, see, you have to, first of all, you need joint PMF in the numerator part, and the denominator part, you need the marginal density of y, right? Okay. So what should be your first approach? You have to calculate the marginal density of y. Okay, so let me solve this question. Okay, so that you can get some idea. So this is question number 3. So what question 3? So fxy is given as fxy, x comma y is given to us as 3xy. Okay, 1 minus x, and what are the supports? 0 to 1, y to 2. So x is 0 to 1 and y is 0 to 2, right? We take value 0 otherwise. Alright, so we have to calculate probability x greater than 3 by 4, and given that y equal to 1 by 2. So what are the things we are interested? So first of all, this will be joint density in the numerator part of when x is greater than, basically this means x is greater than 3 by 4 and y is half, and the denominator part will be fy half. Yes or no? So first we need this, right? Fy of half. So first what we will do is we will calculate fy of y, and then at the end we will substitute the value of y. So what we have to do, we have to calculate this marginal density of y. Then what I will do, I will integrate this joint density with respect to y, right?
X.
X, correct. And what is the support of x? 0 to 1. So it will be 0 to 1. So you can see this is 3xy and 1 minus x dx. So y, basically 3y I can take outside, right? Because we are interested in x only. Yes or no?
Yes, sir.
So
Yes,
this
sir.
will be 0 to 1, and it will be x into 1 minus x. So x into 1 minus x dx, and this will be 3y. So it will be x 0 to 1 x dx minus 0 to 1 x square dx basically, and then it will be 3y and it will be x square by 2 minus x cube by 3. Yes or no? Would you agree with me? Because integration of x square and dx is what? X square n plus 1 divided by n plus 1. Right? So it will be 3y 1 by 2 minus 1 by 3. Correct? Basically, this will be 3, 2, 1 y by 2. Yes or no? So f y of y is 1 by y by 2. So f y of half will be how much? 1 by 4. Correct?
Yes, sir.
Now I have to calculate the fx given y is equal to half and was not like this. So this is saying probability x greater than 3 by 4 given that y is equal to half. So we saw it will be joint density when x is greater than 3 by 4 and y is half and divided by fy of half. So this denominator part which is already we have, which is 1 by 4. So if you substitute 1 by 4, so this will be 4. I mean, just 1 by 4 if you go, it will go to this part, right? Now, what is this case? What is the fxy? Fxy.
So substitute y at half and
Y at
complete
half, correct.
Integral from 3 by 4 to 1.
So basically, so it will be fxy, x is greater than 3 by 4, comma, y is equal to half, and this will be 4. So if you see fxy, x comma y is 3xy, 1 minus x. So what is the y? I'm substituting y as a half, right? So it will be 3 by 2. Okay. So fxy, basically what I have to do? What I have to do here? Tell me. I have to integrate x 3 by 4 to 1. Right? This is 3 by 2 x into 1 minus x dx. Is this okay? Is this clear to all of you?
Yes, sir.
Yes, sir.
But is 4
by 2 like upon 2 is.
Yeah, so 3 by 2 here. We have to, it's given, then I'm interested y is equal to half, right? So y is equal to half, I will substitute, right?
Yes.
Okay. It will be 3 by 2 x into 1 minus x. Now this is just a function of x. I will integrate throughout the limit of x. So this will be 2. It will consider it will be 2 times. So basically 3 I can take outside. So 2 into 3. This will be 6. And again I have to do integration of 3 by 4 to 1 x dx minus 3 by 4 to 1 x square dx. Are you getting my point?
Yes, sir.
Okay. So once whatever the you have to solve this, you have to just solve this, you will get the final answer. So let's see from the PDF what is the. Yeah, same thing. First you have to calculate the marginal and then substitutes. Yeah, the same calculation. So answer is 5 by 32. So what I wanted to give you here, like this, how to solve this conditional probability quantity. Okay, is the rough idea okay?
Yes, sir.
Okay.
Sir, can you please show the calculation of marginal again?
So we have very few minutes actually because you have math session. If there is no math session, I could extend the session. But anyway, yeah, this is the answer.
इसका एक्सेस हमें कहाँ पे मिलेगा?
So this session will upload on the portal and the supplement.
And sir, could you please upload this session notes PDF in calendar?
Yeah, all right, sure, sir.
Okay, thank you.
Okay, so this is again one of the question. Okay, so just okay, so you want to try or should I give you time?
You only solve, sir.
Okay, let me try to give you something. Okay, this one. So question says the amount of milk in liters in a shop at beginning of any day is a random variable x, from which a random amount y in liters is stored during that day. Assume that the joint density function of x and y is given by like this: 2 by 25, and limit of x is 0 to 5, but y there is restriction, right? Y is 0 to x only. So question, what is the probability that amount of milk left at the end of the day is less than 2 liters? Okay. So what is the question? Question is probability amount of left. Okay. Amount of milk left. How will you write amount of milk left in terms of mathematics notation?
X minus Y.
X minus Y, right? So what is the question? Question is probability X minus Y less than 2. That is something we have to calculate. Yes or no? So let's see the next.
Yes.
So this is the graph. So what is the if you see X is 0 to 5, right? And but Y is restricted till X only. So first, what I will do, so I told you, right, whenever you have been asking any questions such that, just draw a line X equal to Y. So if this OOD represents the X equal to Y, right? And this AC represents the X minus Y equal to 2.
Yeah.
Right. What is the probability? Which area is probability X minus Y less than 2? Orange one or blue one?
Blue one.
Just think X minus Y less than 2. Orange line or blue region?
Less than 2 will be orange region.
Orange region, right? X minus Y less than 2.
Yes, sir. X equal to Y plus 2. X equal to Y plus 2.
No. Basically, Y has to be greater to become this as less than 2.
Less than.
Y has to be greater than X. Yeah.
Okay. So the orange one is the area in which we are interested. Okay. Yes or no? You got the idea? X minus Y less than 2 part. Okay. Just substitute values also. You will get some idea. Okay. Suppose you can see my cursor here. So what is this value? Suppose X is close to 4. What is the Y? Some around 3 or 2.5. Is this difference less than 2?
Yes.
Something like that. Okay. Yes. This is the one way to approach. Okay, so I'm interested in this orange region. How I can calculate the orange region? It means OACD. So if I will subtract this area of OBD, the big triangle minus blue triangle, then I can get the orange one.
Yes.
That is the one of the way, right? Okay. So what I will do in the next question. So if you see, first of all, what is the area of? Okay, let's not do like this. Tell me what is the area of OBD? Half into base into height, which is
formula of triangle.
See, what is
12.5?
25 by 2, right? Base is 5 and height is 5 for OBD, the big one. You can see my cursor, right?
Yes,
area,
sir.
Right. So the total area is 25 by 2. Correct. Now, what is the favorable case? Favorable case, I need this orange. So what I will do first, just calculate this area, blue one. So it will be half into base into height. So what is the area of blue? Half into, tell me what is the base? How much it should be?
3.
And height is also 3, right? So it's a 9 by 2. Yes or no?
Yeah.
So what is the area of this orange region? So big one was 25 by 2 and this blue one was 9 by 2. So 25 by 2 minus 9 by 2, that is 16 by 2, that is 8. Understood?
Yes, sir.
Area of orange is 8, right? Now I need the probability. Till now I have calculated this area. So to calculate the probability, what is the what will be your approach?
Into 2 by 25, the PFX.
Into 2 by, yeah, basically it's favorable case divided by total case. So favorable area, this area of this orange region is 8 and total area is 25 by 2. So 8 by 25 by 2, basically it will be 16 by 25. Understood?
Yes, sir.
Okay, so this is the way you can see, right? Without integration, you can solve this. 16 by 25 will be the answer. That's something, whatever we have discussed. Okay?
Sir, can you show the solution again?
Yeah, this is a solution. Okay, don't worry, PDF will be uploaded. Okay, if you are taking screenshot. So let me give you the idea about this next question. I think it's already 8. Math session is started or there is any delay? Okay, so this joint PDF of two random variables given to you, fxy is 3 by 2 x comma y, and there is something you can see, x is between 0 and 2, y 0 to 2, but there is one constant, x plus y should be less or equal to 2. So how will you draw the graph? Okay, so if you see the, first of all, you have to calculate the marginal density of x. See, x is 0 to 2, y 0 to 2, x plus y equal to 2, I can draw this one, right? And the red region, x plus y less or equal to 2 is the red region, right? Yes or no?
Yes, sir.
If
Yes,
I
sir.
want to calculate the marginal density of x, what I will do, I have to integrate with respect to y. So I have to calculate the limit of y. And what is the approach to calculate the limit of y? You have to draw a parallel, right? So if you draw this line parallel to y-axis, what is the limit of y here? It is going from 0 to 2 minus x. Understood? So what is the value of y? 0 to 2 minus. So what you will do, you will integrate from 0 to 2 minus x, 3 by 2, x by dy, you will get the answer. Okay. Tell me, what about if I want to calculate the marginal density of y? Then what will be the limit of x?
2 minus y only. 2 minus y, I think, yes.
Only 2 minus y. Is this good? I mean,
0
is
to
this
2 minus y.
0 to 2 minus y. Correct. So if you solve this, you say you will draw a parallel line with respect to x. It's at y-axis, limit of x is 0, right? Value of x is 0. So 0 to 2 minus y. Clear? So you can see there's something we have discussed already, right? And the next question is, are x and y are independent? So how will you approach? You will see whether joint PDF is equal to product of their marginal PDF or not, right? So joint PDF is, you can see, you can easily see joint PDF is 3 by 2 x into y. Marginal is, you can see for f of y something else, for f of x something else, but product of these two is not same. So you can say f x y are not independent. Is this clear?
Yes.
Okay. So the next question is again based on this 2D inform. You can try it out. We'll upload the PDF. Yeah. Okay. So I hope you have learned something how to solve this 2D integration and all. Okay.
Yes, sir. It was very helpful.
Okay, just try to solve. The PDF will be uploaded on the portal under supplementary content. Okay, so just try to solve the questions again without seeing the solution first. Okay, all right. Okay, so please you can go for math session. Okay, thanks all.
Thank you for the session, sir. Thank you very much.
Thank you. Bye.
Thank you, sir.
Thank you, sir.
Thank you, sir.